You're listening to a Pub House Network podcast for developers by developers.
Hello and welcome to the Stackd podcast episode number 76, recorded on January 31st, 2025. This is our first podcast of the year and the first one in a couple months. So thank you for joining us. Happy to be back. And this time I'm here with one co-host, Daniel Inahosa. Hello, Danno.
I'm the only one you need.
Yes,
That's not true.
I only need one other co-host, because otherwise it's just me talking to somebody, and it's kind of
yeah, that's right.
So this year has been sort of a annoying year for me so far, but just there's a lot of my wife's been sick. Kids were out of school for like a week. It snowed here a lot, and there was all this ice. There were water issues because all that ice ruined the water supply. It was a lot of fun.
You're in Nova, right?
Yeah, well, I'm actually in Richmond, so I'm like 2 hours south of Northern Virginia. So, yeah, so it's been fun. And then work's been busy. I've been working with legacy Java stuff, doing migrations and upgrades, and also doing some Vue stuff, which has been kind of fun. So, so all that stuff is moving along. What have you been up to, Danno?
I just got done with a 5-day domain-driven design class, and I still ran out of time. So, yeah, I quite enjoy it, I've been stating things like I think domain-driven design is the cornerstone of everything. So, really enjoyed that topic, and finding more and more about it. So, really nice.
It would be nice if more people did it, because I never get a chance to actually do that. So
It's a deep topic. Yeah, someone asked me like, can you cover some DDD? And I'm like, how much harder is it than TDD? And no, so it's like totally different. And yeah, that goes deep. That road goes pretty deep. So, but enjoyed that I've came across it, and since I do a lot of Kafka and messaging now, and fell into architecture because of it, it's just a really great topic.
good deal. Good deal. All right. Well, we're very happy to have our first special guest of the new year, Mr. Brian Sletten. Hello, Brian.
Ooh, Brian.
Howdy. Happy to be here.
So I will give you Brian's CAN bio. He's a independent software consultant, but he's also a liberal arts educated software engineer with a focus on forward-leaning technologies. This is actually true. I've watched him over the years. It's like everything he's talking about is what people will be talking about in the next 3 or 4 years.
Yeah, I call him the prognosticator. So
yeah, it's absolutely awesome. So his experience has spanned many industries, including retail, banking, online games, defense, finance, hospitality, and healthcare. He has a BS in computer science from the College of William and Mary and lives in Auburn, California. Oh, so you went to school like 2 hours from me.
Awesome. Like half an hour from you, 45 minutes.
Yeah, actually, I was thinking, yeah, it's like 45
from
minutes.
DC, yeah. I loved it.
Nice. I have my nephew's going there, and then I know a couple other people that have applied. We'll see if we'll get in. But it's awesome. So welcome to the show. It's good to have you.
Thank you.
As
you said, it's this year has been quite a year so far.
Yeah, I have not been thrilled, and it's not just whatever it's not like the political climate or anything that like that. It's just like the whole year just seems
tense.
And
it's only January.
I know. I'm a little nervous. I'm like, every day I'm like, I guess I'll just pretend like everything is normal and just keep on going, because
Yeah.
What else can you do?
Yeah. Exactly. So Brian, you have been another no fluff speaker. So that's how I know you, and that's how Danno knows you, right? How long were you doing that? Or how long have you been doing that?
I've been doing it for about 20 years now.
Oh my God.
I was introduced to Jay through Rod and Bodkin, who I knew through the aspect-oriented programming world. And I didn't have a book after my name at the time. I wasn't associated with any open source projects or anything. I just kind of had this idea that AOP was going to be interesting from a design perspective, and Ron encouraged me to approach Jay, and he and Stu were in Nova for a meeting, and I approached him, and this isn't how it went down, but in my mind, I kind of imagined myself walking up to Jay and be like, "Excuse me, Mr. Zimmerman, could I speak at your conference?" And his response was, I'm sure, gracious and whatnot, but in my mind, it was kind of like, "Go away, son, you're bothering me." Foghorn Leghorn. Um, but about a week or so later, I realized that some of the guys that he used for the Northern Virginia show, like once the rock stars left, there's usually some like regional people he used to have kind of close out the show, and they had heard me do my talk that I gave to the Java Jug, and I wrote back to Jay, and I'm like, they didn't know that I'm interested. Why don't you ask them how I did? And
Oh, that's
I
cool.
guess that's the kind of initiative he likes or whatever. So he was a little more optimistic about something, and then literally the next day, he calls me up to say, "Hey, Brian, James Gosling had to cancel a talk to the New England Java Users Group. Would you like to go replace it?" So my first talk for the No Fluff tour was as James Gosling's stand-in, and it was to 250 people in New England, and thankfully they didn't throw anything. So
Nice. Now, how many
Wow.
of them were like
Wow.
were there for James? And I'm like, wait, you're not James.
I don't know. I mean, I'm sure there was some confusion, but I did the best I could, and it must have gone well because he started inviting me to more of the shows, and I've been happily part of it since then. I like
Nice.
the energy. I like the approach. Um, the fact that it's generally like personality filters and things like that to keep everybody from being kind of too full of themselves and very
Yeah,
accessible, and so it's a lot of fun.
it's awesome. So, but before I do want to talk about a little bit of industry news, but I want to do a bit of a teaser first.
Mhm.
So Brian, what topics are you talking about these days? Like,
Um, a wide variety. I had kind of gotten tired of ML and machine learning and data science and things like that for a while, and um, right before the pandemic, I started suggesting I wanted to identify some topics that I thought had proven themselves. Like you said, normally I focus on things that are coming, and there's a certain amount of, hey, trust me. But I wanted to focus on things that I thought had already established themselves, and people weren't really noticing. And I threw them into a bunch of just kind of like an umbrella topic of like modern software development, and didn't think much about it. But the one conference we did before the pandemic took off, as I was giving these unrelated talks, I kept saying to myself, well, in this one that's coming up, and in the one I just did, and the one that I'm going to do tomorrow, and I started to realize that there was a connection there, and I I've started to develop kind of a theory for IT in the 21st century around this kind of like very multidimensional combination of technologies, and I'm trying to come up with a better elevator pitch on it because it takes a long time to describe. But effectively, it kind of comes down to two main benefits. It's for the business, it allows you to focus on things that kind of have legs and long-term value capture, as opposed to like shiny objects that people like to chase. And as far as developers, a set of technologies to kind of focus on, or at least to kind of understand what's happening in the industry, and I think kind of build careers around some of these things. And so it's a combination of things like WebAssembly and LLVM and some of the newer languages that are coming out, and linked data, right, as a way of connecting information with sort of low cost data integration. Um, and so it's really kind of like a vision of a bunch of technologies that work together to provide value and solve problems, as opposed to, you know, typical organization will hire a CIO or something and then like chase one vision for 2 years, and then it'll fail, and then they'll hire a new one, and then they do the same thing for another 2 years. And
Mhm.
you're spending money constantly. Um, and you're still going to be spending money in kind of my vision, but the goal is to have it be additive and accumulative, and incremental. And it largely comes down to don't spend more on computation than you need to. And
Hmm.
it's kind of a coarse summary, but I think that's really our job in the 21st century is to reduce the cost of computation. And that's wall clock cost, money cost, power cost, opportunity cost, latency cost, right?
Mhm.
Um, all those things go into it. And so it just comes down to where do you put stuff, and how do you access it?
Okay. Very high level, but that's kind of interesting.
Well, it's simultaneously high level and also very low level in the
Yeah,
sense
yeah.
that it also involves the heterogeneity of hardware platforms and where
Mm.
things run, and how do you mediate those differences in terms of computational elements. So it's all over the place.
Well, I think that was a great teaser. I'm really intrigued now. Uh, so, all right, so we've just got a couple industry news topics, or a couple topics before we dig into Brian's brain a little bit more. So for industry news, you had a couple there, Dano. You want to talk about
Yeah.
our beloved social network, Facebook?
Uh, which one? Oh my gosh. Yeah, there's the other one, and oh my gosh, and then
Yeah,
here's
beloved is
this
not
one
quite the
here.
word I'd use for any of these networks.
Yeah, yeah. So Facebook blocking distro watch, and a little bit of confusion there, and I'm still a little bit confused, but I guess Meta blocked distro watch, which talks about Linux on Facebook, which and also they run Linux servers, so there's kind of a little puzzling effect there as to why they did that, and um, the someone says here, rich irony is that Meta servers run Linux. Company is public about this. It's one of the biggest known users of CentOS. So no one's sure as to why the reason is for this, or what the issue is when it comes to blocking distro watch. So kind of an odd thing.
Yeah,
But they don't block misinformation anymore, so maybe they're just blocking information.
That's right. Yeah.
that's exactly what I'm thinking. It's like you got rid of actual moderation, and this is what you're blocking. Hmm, okay.
Yeah. So
It's,
yeah, we'll see what's happening here.
mhm.
But yeah, social media is Um, Brian and I are on Mastodon. I absolutely love Mastodon. It's as a social media. One of the things I was telling Brian about is that you're not being manipulated because the top couple of stories may just actually be boring, right? It's not.
Yes.
It's just like, hey, here's something if you're interested in,
Well,
and
yeah, and there's not ads thrown into it, especially like I'm on Facebook largely because the whole, old family friends thing. I'm
their
stuck there
families
for,
there. Yeah,
right? And like all these people I knew from high school and stuff like that.
that's typically
So,
why people are there. Yeah,
yeah, exactly. But I go
I
on there now. I see all this crap that I have no interest no interest
and it's
in.
there to make you angry. I know Twitter did that, and one of the
Yeah,
reasons why I left is just
yeah.
the anger stuff bubbles up, man.
Yeah, and I'm on Mastodon. I finally stopped using Twitter, although my account's still there. I'm not going to deactivate the account, but I'm just not going to use it.
Yeah.
Um, and so I hang out on Mastodon, and I created a Blue Sky account. I don't really have any. I don't hang out there, and no one's following me, but it's there.
I think most tech people, especially in the Java space, well, I think in every space, every, notable developer and whatnot have moved over to Blue Sky
Yeah,
for
that's
that.
why I
They're not
joined. It's like,
necessarily open,
yeah,
and we're going to talk about what open means anymore, but
yes,
um, it's
Dano's been trying to get me to come to Blue Sky for a while, and um, I had no interest in it, and I still don't have much interest in it. Um, but I will acknowledge that, that's where everybody has gone, and that's where everybody is. But what I've found so far is, you know, people are there to kind of like watch what other people are doing, not necessarily to be creative or like engage. And I find engagement on in Mastodon so much better
Me too.
with fewer people there. People are there just to kind of like hang out and connect and find their tribe and I think there's a lot of concern amongst media theorists that the whole concept of Twitter and Facebook is ill-conceived to begin with because of the whole context collapse. We don't live in a global social space. We live in circles, and when you try to collapse all of those circles into a global social space, the kinds of hassles and things that people have had are there. So I don't actually long for a return to that. I have
Yeah.
enough people on Mastodon that I find interesting, even as it is, even if nobody else shows up. But it's a good vibe.
Yeah. Thing I like about it is the self-hostedness of Mastodon, where if you want to create your own social media server, go
Mhm.
for it. And
Yeah.
you bring up your own Mastodon instance, whether you're federated or whether you're blocked from everyone else. That's the world's prerogative there, but you have some ownership of your data. I think um, we need to move towards that, whether we actually
Yes.
will or not. Who knows? But that's
Yeah.
a good
I don't
idea.
know. Sometimes I miss the days of Usenet. So
Hmm.
Yeah,
may not have been moderated, but
yeah,
a
yeah.
lot less stressful.
So Brian, what's the name of your WebAssembly book?
WebAssembly, the definitive guide,
All right.
O'Reilly. Yeah.
We'll
Um,
we'll throw that in the show notes.
it's uh it's slightly out of date now just because there's so much that's happened since then.
Yeah,
But
you were
the
telling. Yeah, go ahead.
the main ideas are still there. And then the things that have happened since then are like uh, the WASI interfaces and the WebAssembly component model, which are very, very, very adventurous, but they're falling into place, and I think are going to make it really cool so that you can write components in any language and compose them together into like Uber components, even if they're different languages. And they even have a mechanism so that you can mix different asynchronous models. So like something could be written against async await and then run with libuv runtimes, and that's pretty trippy. Um, and it's a different way of thinking, and it falls into the topics that we discussed that I mentioned earlier, like longer term value capture, because you can write something and then just kind of use it inside the browser, use it outside the browser, use it in edge computing environments. Um, and at the same time, um, you can have maybe a little bit less concern about supply chain attacks because these things can all be run in sandboxed environments where there's no access to the network or the file system. And you can even have sort of like provenance chains around the code. Because you have these encryption experts who use formal methods to prove that their algorithms are correct and aren't subject to timing attacks and things like that. And then if you want to bring those algorithms into the browser, usually some developer who's maybe not an expert in encryption is trying to translate those ideas into JavaScript, and it can lose something in the translation. So just being able to take a library with the provenance that it has and recompile it to run in these different environments, I think is a key part of that as well.
Brian, let's just take a step backwards. For
Sure.
for those who don't know what WebAssembly, can you just explain what it is?
Sure. It is in scope probably the most interesting thing going on in our industry. Um, and that's both a strength and a weakness, right? It's a strength in the fact that it has tremendous opportunity to solve a lot of very hard problems that we have. And it's a weakness in that people are very focused, right? And they're focused on, specific technologies or specific versions of technologies. and something that is this kind of like open-ended is a little bit confusing. So basically, the browser is extended when the W3C members agree that something is important enough to spend time on adopting, right? They don't want to have people tilting at windmills and creating stuff that nobody would actually use. So there's a certain effort to get a new technology um, granted permission to be considered as a standard. But it has to go through a community group mechanism, then a working group mechanism, and then you have to decide if the browsers even want to support it, right? So extending what's possible in the browser really has only involved changing the standards, which can take years, or using JavaScript, which has been effective, but as an interpreted language, there's just certain classes of problems that aren't well suited for that, and it's got no capacity for real ahead of time optimization. And then there's just this constant need to rewrite stuff, right? Which is annoying. Um, and so WebAssembly emerged out of an attempt to try to fix that problem by establishing an instruction set. It's a stack-based abstract machine. You compile code down to these instructions, and then those instructions run within a sandboxed environment. And if this sounds like Java, yeah, it does. It's the promise of Java with like 30 years of experience. And they're trying to avoid some of the problems that I think Sun initially made for themselves in terms of like having to rewrite everything, right, in AWT or Swing, or everything has to be in Java or this platform, which for a while was okay, but then other languages evolve and things are written, and there's just no real strong way of tying them all together. So it doesn't try to over specify what's there. Um, and in its first minimum viable product, which has been supported in the browsers for 7 years now, there's no garbage collection, there's no threading, there's nothing like that, which sounds pretty much like a showstopper. But if you've seen any of the things like, Linux running in the browser, or Postgres and DuckDB and things like that running inside the browser, you can see that it's not really a showstopper. They just wanted to see how people would use it before before they like over specified the platform. Since then, there have been a series of extensions for like 64-bit address spaces, tail optimization, um, you know, uh, garbage collection, threading models, and things like that. Um, and part of the problem is, we can map new features. Venkat's got a new book coming out on like all the new features in Java that are coming out like over the course of like 10 versions. So
Right.
you can map a feature to a particular version of Java, but with WebAssembly, individual platform implementations decide which of the new features do they want to support. So they announce whether they support garbage collection or 64-bit address spaces and things like that. And that's again both a strength and a weakness. It's kind of you sort of have to know or test what capabilities are available, um, rather than know that you can target a particular version. But in practice, it's working out pretty well. And so we moved outside of the browser. That's one option for running these things. But there's also server-side backends. There's support in Node and Deno. There are runtimes that called Wasmtime that has a capabilities-based security model, so that you can't access the file system or open up network connections unless you're given permission to do so. And then there are now edge computing environments that are designed for multi-tenancy, serverless function kinds of things. And we're just kind of moving away from this idea that you have to have an entire operating system and application suite and even set of components, right? That have to be there and have to be kind of versioned and managed in these environments, to just being, hey, I need a series of capabilities that are expressed through this kind of like language independent interfaces, And as long as you give me those capabilities, then I don't need to worry about what I'm talking to. So there are things like key value services, right? I just need a place to store key values and look them up. I need a way of writing to something that pretends to be a file system. It may be an actual file system, it may be local storage, it may be writing to your S3 bucket. Like applications just don't know these things, and they shouldn't know these things. And so the context of what actually is running in these different environments can shrink and shrink and shrink. And now you see the coherence of things like serverless functions, architecture as a means of, you know, managing the the coarseness or the fine-grainedness of your deployment model, and edge computing environments as solving real problems, right? So you can have something that literally spin up in nanoseconds, answer a question, spin back down, and you know, the whole serverless function mechanism suffered from the cost of spinning up the instances. And if now the containers can be small enough and fast enough, then this gets back to what I said was one of my fundamental points. You don't need to have services that are sitting around waiting for somebody to talk to you, right? You can just spin up, answer the question, spin back down, and that's the cost that you pay for, right? That's your cost of usage, that's your cost of you know, money and time. And because you can locate them with high fidelity, um, you know, edge computing is kind of like very fine-grained um, cloud regions, right? You can imagine like a data center around cell towers, right? And you can then deploy code to the cell towers, and now you're geographically distributed. You're close to where your users are. You have low latency interactions, and you can also just kind of spin up, you know, sandboxed code to respond to requests in a very short amount of time. And so again, this whole vision is about having a computational landscape of where arbitrary code written in arbitrary languages can be deployed into arbitrary environments, which again sounds very familiar. Um, but once you throw out the heaviness of the container, that actually gives you the ability to work with microcontrollers and embedded systems and in the browser and in these sort of environments that aren't going to have the same resources that, you know, shared cloud instances would. So it's fascinating, and that's why I was drawn to it. I've been tracking it since, you know, the early days with ASM.js, which was a proof of concept prototype. But the component model slowed things down, right? There's a lot of interest in it, and people got excited, and then they realized in order to actually have these software systems that can talk to each other from different languages, you needed a way of representing data structures in different languages. And that's where kind of the interface stuff comes from. But like I said, they're getting to the final stages, I think, of a releasable version, and that's gonna accelerate the interest again.
So it's interesting because hearing your talk, you know, when you say, you know, interface and communication in different languages, I think of things like Corba and
Right.
things like that. When you say running on little devices, I think of Java.
So
But
and you're not incorrect, right? I mean, all of these ideas have influenced the thinking, but all the failures of these things have also influenced the thinking as well.
exactly,
And you know, there's no telling what's going to happen, but you know, so far it looks to me like it's got at least the potential to really change a lot of things about long-term value capture, about avoiding supply chain attacks, avoiding ransomware and malware, making code be able to be composable, you know, with other code, regardless of what it's written in, allowing the language to be used for reasons that benefit the solution that you're building, right? Rather than saying you have to use JavaScript, right, which is kind of a solution space answer, you can pick a Lisp or a Rust or a Julia or whatever, even Java, right, and target this platform because there are better tools or things that are already there, or just the language naturally lends itself to the problem at hand. But that decision doesn't have to then expand and taint everything else. Like, and this is ultimately like I think the problem with Ruby on Rails. Everybody loved it as a development environment, but as a runtime environment, it kind of sucked from a performance perspective and everything. Um, and in order to build libraries and things around it, everything had to move to Ruby. And again, there are reasons why people didn't want to do that. Um, as great of a language as it is, so that's kind of the lesson learned from I think Ruby on Rails. The lesson from Java is the heavyweightness of the runtime, and the fact that everything had to be moved to this was challenging. And then for Corba, the the whole service composition directory discovery thing, same thing with UDDI and WSDL and
Yeah.
everything.
Yep.
The overhead was too high. So if we solve these individual problems, and yet we can reuse existing code and innovate in languages in ways that don't taint the runtime environment, that's why I think it's different.
So one of the things I was looking at, because with WebAssembly, I've been sort of paying attention like on and off over the years, but obviously not terribly deeply. But one of the things I was always wondering about is like, what is the interop with JavaScript in the browser? Like, what if I am writing like a UI using the DOM, you know?
Oh, that's the best case scenario currently,
Okay.
because JavaScript code can call into the runtime environment, the WebAssembly environment, and the WebAssembly environment can call into functions that are passed in from the JavaScript environment.
Okay.
So if you say, give me a function that accepts, some numbers, and then I call that, those numbers could then be printed out to say like console.log, right? I don't have direct access to the console from within the WebAssembly space, but if you give me a function that calls that, you can manipulate the DOM. You can do anything that you can within the JavaScript environment. Um, Early versions, there were some pretty serious performance issues going back and forth, but they've resolved those. Like they're 1,000 times faster now.
Okay.
And so that's actually, that's like I said, that's the easiest, best case scenario. The harder thing is if you want to start writing applications that run both inside and outside the browser, because within the browser you have access to the DOM, you have access to the Fetch API, you have access to Canvas, you have access to WebRTC, you have access to everything that's in the browser, but in Node you don't, right? And so that's why one of the things that I like about Deno, in addition to the standard library, TypeScript, the the capability, security, and everything, is they're trying to replicate as many of the internal interfaces in that environment as well. So code is completely portable
Oh,
between
interesting.
the front end and the back end.
Okay. Cool. I have one last question, and then we can get on to some of the other interesting topics here. So I've noticed that I've been following GraalVM for a while, even though I haven't really had a really good good reason to use it on projects.
You said
Uh,
GraalVM?
yeah, GraalVM.
Okay.
But they do have interop now with WebAssembly.
Mhm.
And so, and I was sort of hoping that was one of my first questions to them is like, what about, WebAssembly interop? And so it's interesting to me because GraalVM sort of does try to do the polyglot thing. I think it's undersold in that area. And I'm wondering like what you think about like interop between those two, or if you think like longer term it would just be like you write Java or C and everything goes to WASM.
Right. Um, eh, eh, in the Java space, I'm not particularly popular for saying this, but um, I don't see much value to the JVM long term, right? So to me, GraalVM only matters if you care about the JVM. It's an attempt to keep the JVM viable in the face of what things like WebAssembly are going to facilitate. Um, and it does a nice job of that. But again, if you don't care about the JVM, then you're not going to care about GraalVM. And you say that you think they undersell the polyglot nature of it. I think they oversell it. Like the first time I saw it, um, the demo was like Python code calling Ruby code, calling JavaScript code, calling Java code, and I thought, What are you smoking? Like that is not a useful use case. Um, and that may sound like it flies in the face what I said about the component model, but the component model has a standard interop mechanism, right? So you're not mixing Python and Ruby at a code level. You're interacting with bindings generated from the interface definitions in your own native language. And so, the JavaScript calls JavaScript and the Ruby calls Ruby and the Python calls Python. Um, because I think anything else is just madness. Um, so, I think the engineering that has gone into GraalVM is fantastic. But it's solving a problem that I don't particularly care about. And I think based on usage, I don't think many people do.
Yeah.
Hey, yeah, I see what you're saying there. Okay, cool. Any other questions, Dana, before we move on to
Yeah, I was just thinking, are these, and maybe you answered this one and I wasn't paying attention, are these interfaces to where like I could use Python to call, a Haskell or a C or a Java or whatever? Can they be used outside the web, or is this just all, I know it's
Oh, no, absolutely.
WebAssembly. Yeah.
No, absolutely. So again, the idea is rather than building necessarily an application targeting, say, the Win32 environment or .NET or Linux, POSIX or something, um, you would basically say, here's a piece of code, and then your interface, it's called a WIT file, WebAssembly interface text file, I think. Um, it basically says, here's what I need to do my stuff, right? So I need to import some kind of capabilities from the host I'm running in, and here's what I provide, right?
Mm-hmm.
So let's say that you import 3 things and export 4 things, right? That basically just defines your world, and now you can be deployed into anything that will provide you what you need and use what you provide, all right?
Right.
And so in that sense, it's generally going to then, as I said, you'll take those WIT definitions and compile them into scaffolding, so that the Python code will call as if it were Python code, um, but it's still controlling um, what it is that you need and what it is you provide. And so this way we can reason about modules. If they don't say that they need file system access, then we don't need to worry about file system access, right? If they don't say they need network access, then that's another thing we don't need to worry about.
Right.
But if you do say that, like I said, within the browser, a file system interface could write to local storage, and then the application would just be unaware of that fact, right?
Right.
And in my book, I did an example like this with a C++ library. It generated fractals um, in the Windows bitmap format, and those aren't supported in the browser. So I just took the C++ library, recompiled it, and the tools that I used generated a file system abstraction. Um, so then the code looked, because it was using like low-level POSIX stuff, it had something to write to, but then it would just write the generated image into local storage, which could then be read in JavaScript and rendered with some JavaScript-based bitmap libraries, because again, the browsers don't support that format. Really, what WASM time in these interfaces is just trying to expand that into a generic mechanism, so
Mm-hmm.
arbitrary capabilities can be provided, and then the host environment decides what you have access to. And that's where a lot of the security comes in. That's where a lot of potentially the performance will come in. You don't have to feature test. Do I have a GPU available? Do I have, how many CPUs do I have available? You can just like write code against interfaces, and they can provide like a hardware-backed implementation, kind of
Okay.
like TensorFlow JS does. But like I said, it's just a more generic approach.
right?
Wonderful.
Okay, I do have one more question. So for people who don't know, or even for me, like you mentioned a few examples of apps, of things which have been done, like running Linux in the browser, etc.
Mhm.
what are some applications that people actually use that that actually are written, are deployed in WebAssembly?
So a lot of, again, things like encryption libraries, modern encryption
Mhm.
libraries can be recompiled. TensorFlow JS has multiple backends, and one backend is just running JavaScript on a CPU, which runs badly everywhere. Um, then there's one that uses WebGL, so it pretends to do 3D graphics, but it has indirect access to the GPU that way. Um,
Interesting.
Once they released, they turned around and created a WebAssembly backend. And that may seem like, hey, they're starting from scratch. No, they took a C++ library, recompiled it, and now it's available in WebAssembly. And the value proposition there is the code could run in a variety of places, right? It could run in a browser with a GPU, or it could run on a server with no GPU but a powerful CPU, right? And so now the WebAssembly backend, which effectively was just recompiling C++ code, um, provides a performance level for server-side deployment of the same code. Like your application is written against an API, but the backends provide these capabilities.
Right.
Um, and therefore your application doesn't know where it's running or anything. But you're able to take advantage of native libraries or multiple GPUs or vectorizing instruction sets on your CPU. So things like that are happening all over the place. Um, the edge computing environment, things like Wasm Cloud and everything are really taking off. One of my favorite examples, there's a company in London um, called Red Panda, Red Badger, I can't remember, a consulting company. They deployed an application across three separate cloud providers, right? For redundancy using
Mm.
WebAssembly and these sorts of things. Um, because the code and everything is just that portable. And
Right.
good luck trying to do that with Kubernetes or something, right? And again, that's kind of the point is that the complexity is there when you need it, but it's also can be hidden. Um, and so this is part of the problem is like it's finding its way into more and more things, um, but it's not really people don't draw their attention to it.
Right.
Blazor from Microsoft um,
Mhm.
uses WebAssembly as an implementation detail that it
Okay.
doesn't touch their development environment at all, right? But it facilitates building applications that can kind of render on the server, render on the client, whatever. Um, there's a platform called Uno that provides pixel perfect um, similarity across the web and Android and iOS and Windows and Linux. And again, they use WebAssembly as an implementation detail inside the browser. Um, so again, you could literally write an application that will look the same across all of these different platforms if that's your goal. And in that case, it's another implementation detail. So um, it's it's coming in the sense that more and more um, you can just spin up instances of stuff in your browser instead of in the cloud. Um, but people are coming up with all kinds of crazy runtimes and like Python. Python now runs in the browser using
Mhm.
either a C Python based engine or a MicroPython, which is a Python 3 implementation in 300 kilobytes, right? So it's a 300
Holy moly.
kilobyte runtime, which again, we're talking like instant starting up the container, and that tries to hide the differences. So you can manipulate the DOM from Python. Um, so if you look up PyScript, that's a good way to get into that.
So, and is this how sites like Stacklets and ones like that have run all this stuff in the browser? Is that basically what they're using?
I'm not familiar with them,
Yeah.
but it certainly could be. I mean, again,
Um,
people are imagining building development tools, right? And again, a lot of it has been waiting for some pieces of the platform to be extended, but most of those are getting into, I think, some of the final stages that, um, we're going to see kind of a renaissance of uses in different places. But there's also the opportunity to build applications that are identical inside and outside of the browser. So there's a framework, a UI framework called eGUI, um, and it was developed for like in-game user interface elements. Um, but the way they built it, you literally just recompile it and say that you want to target the browser or a desktop application, and the same application looks the same inside and outside of the browser. Um, and I think, once business people start to realize that through things like Blazor and Uno and stuff like that, um, you have that opportunity, then I think there's going to be a lot less interest in JavaScript frameworks, right? Because why rewrite stuff if you can recompile stuff?
Mhm.
And so, I don't think that JavaScript frameworks are going away. I just think it's not going to be the default solution in many cases, where it doesn't make sense to be.
Right. Right.
Yep.
Right. Awesome. Okay, so Danno, you wanna start the next topic?
No, I'm just kidding. It's such
No topic for
a
me.
big breadth here for LLMs. So many of you have noted that OpenAI, what I find really odd, I'll preface it with this. Who's the CEO for OpenAI? I just forgot his name.
Sam Altman.
Yeah.
Sam Altman. He was stating that the world is going to probably run into chaos first because of AI, and I'm like, man, that's bleak. He could have been right. I don't know, but I found it kind of intriguing that following the next week, his world upended, not necessarily everyone else's, which is a neat little irony there. But I guess there's a new LLM model called R1, which DeepSeek started with, which can run a full-featured LLM, much like OpenAI, but far cheaper. From my initial understanding, it is using one LLM to do initial processing and then spawn them off into other child LLMs in order to do it. And it really caught the US off guard and a lot of the US LLM companies off guard because now Chinese companies are able to do it a lot faster. And if you do a Google search as of today, January 31st, and just look for R1 LLM, I think either OpenAI AI had implemented it, Microsoft had implemented it, and it's all on the news sources right now. So,
Oh, really? Okay.
yeah, so I found that really intriguing as
Did
well.
not take
So,
long.
what's that?
Did not take long.
Yeah.
Well, so here's the thing. This is kind of a nothing burger, right? And people are just so interested in crowning somebody as like they're the winner, they're the best and whatnot. They're just like, oh, well, we have to change our thinking and crown somebody new here. But there's nothing substantively better about DeepSeek other than the efficiency. It doesn't do anything uh, better. It doesn't solve the hallucination problem. Doesn't and things like that. Um, the only thing about it that's like really screwing people up is the fact that it's Chinese, right? And now there's all these attacks like, oh, they must have stolen it from us, and says the guy who was literally begging the British government to allow them to continue to steal stuff. Um, you know, it's it's a it's a lot of hype about not a lot of substance. Um, to whatever extent they are the best, cheapest implementation right now, that will change in a week or two or whatever. This is like the top, fastest computer in the world. It's going to change every year, and then everyone's going to learn what everyone else does. And so, um, what you're describing is really called fine tuning, right? So there's usually a pre-training process, which is the expensive one, right? There are only a few companies in the world have the resources to do using the traditional LLM technologies, given the the costs and the energy results and everything. Um, and then you can fine tune that model to do something else. And that's one of the big things about these models is the transfer learning, right? Usually with machine learning, it's you have one task, you have one model. If you want to do something else, you have to start from scratch. But we have the ability to fine tune these models. And so starting with one and producing another that's optimized for a particular use, that's not new. That's been part of the story the whole time. It's just how they've used that um, is interesting, particularly because another part of my big theory is the impact of IT sovereignty, right? Nobody trusts anybody anymore. These are now basically being classified as munitions, and we're having sanctions and stuff against people. U.S. government says, China can't have access to these things. So that forces China to come up with interesting ways of doing things without the access to the latest and greatest um, technology. And
But
that
just
has
to
got,
clarify, you're talking about like the NVIDIA chips essentially.
yeah, absolutely. Um, I mean, so IT sovereignty and the emergence of heterogeneous platforms are very similar. I mean, they're very related. So India is getting into semiconductor manufacturing in ways that they never have. China, while they are sort of world class at like packaging things, they don't have access to the um, extreme ultraviolet, low path design tools that there's really only one company in the world, a Dutch company called ASML, that has the technology to do that. And they're basically being blocked from using those technologies. So you've got China trying to very quickly compete with Western technologies. You got uh, European countries wanting to get away from both the US and China in the European Processor Initiative. And a lot of this is being driven by the emergence of a new open source ISA called RISC-V, which is both open source and extensible. And it's gotten to the point now where like graduate students can design a new chip with a yield of about 100 chips for on the order of like $14,000, and it'll take them a couple weeks. Like previously, it's the manufacturing that people don't have access to, and the manufacturing was not agile, right? You had to sort of like tune the machines towards a particular architecture or design. But now it's getting to the point where the TSMC and even Intel could have done this if they didn't have their head up their ass. Um, they could have become, a world-class manufacturing system for third-party chips. But they were just too proud. Like Intel Inside was the only thing that they wanted to deal with. But what we have now is the ability for people to come up with arbitrary designs and then get them produced for not a lot of money comparatively. And that's giving everyone the ability to innovate. So that's why Apple's licenses ARM technologies, but if you don't have to license it because you have something like RISC-V, just think about how much savings there is. Now, RISC-V is not a comparison to ARM systems from an advancement perspective yet, but it's moving very quickly. And people are designing systems like the M4s and whatnot they're not even chips anymore. They're systems on chip,
Right.
and they come with multiple GPUs and multiple CPUs that are optimized for either performance or power consumption, which is again part of my story. Um, but there's still discrete elements on the system, right? So you send the code to the CPU or the GPU or the neural processing unit or the tensor processing unit, whatever it is. But people are building RISC-V based systems that are simultaneously GPUs, CPUs, neural processing units, and they basically just like reorient themselves to have the structure to run the code that you're asking it to run,
Oh, cool.
all in one place. So it's people are building FPGAs that normally in the von Neumann architecture of paging stuff into and out of memory, um, that's the slowdown now. Memory bandwidth is the real problem. So now imagine you're building a multi-level deep learning neural network structure, and you write the first couple layers on an FPGA, and then the second couple layers, and then the third couple layers, and then the data just like kind of shoots straight through it as you're writing these things out.
Mhm.
Hardware is going to become a huge part of our lives as software people. And in order to do that, you need technologies that mediate hardware differences, which are going to explode in an IT sovereign heterogeneity, everybody doing their own thing, with an open source ISA like RISC-V. Good thing we have WebAssembly and LLVM as technologies that help us write code at the application level that will run in all of these different environments because we have pluggable compiler backends.
So
Right?
let's just unpack that a bit.
Okay.
So for ISA, you basically are talking about
Instruction sets.
right? Instruction set architecture, right?
Mhm.
So basically, you're talking about the idea that a lot of the chip design is no longer going to be completely proprietary, right?
Correct.
So RISC-V is open source.
Mhm.
And you were also saying that now, let's say you come up with a new computer architecture, you can get it built for you.
Mhm.
Now, who actually will do like sort of like low volume contract manufacturing?
Off the top of my head, I can't think. I don't know
I'm
the
just curious
names,
about
but
how that works.
so basically, the investment in manufacturing capability is huge,
Mhm.
but it's the design that's the bottleneck, right?
Right.
And so basically, Intel has done design and manufacturing, right, for decades. Um, but they're like TSMC, right? Probably the most valuable chip
Yep.
company in the world, basically takes designs from different people, right? Um,
Hmm.
and Samsung and was it Hynix, and other ones are starting to do this as well. But basically, design is going to become decoupled from manufacturing. That way, people can innovate on it.
Right.
Um, and honestly, I mean, the way I see this is, you know, we all grew up reading dystopian science fiction, and there's always the hardware modders in the back streets, and you go in and like, hey man, I need a new chip like this or whatever, right? We're kind of heading towards that, right? Where people are going to be able to create custom technology, um, and it will solve specific problems. So when Google first introduced BERT in 2018, and then they rolled it out in 2019, because it was more computationally intensive, they had to roll it out with hardware support. Now they have designed tensor processing units as kind of like a light GPU. It's not focused on the same problem spaces that GPUs do, but it provides a similar parallelization and optimization for mathematical calculations. They had to roll out TPUs for BERT to use in order to be useful. Um,
And BERT is
BERT is a transformer-based architecture that's optimized for things like question answering.
okay.
It was a big part of pre-Gemini, a big part of their
Isn't it?
AI story.
Is it the same as BART, or is it's a precursor to BART as well?
BERT, it's independent. Yeah.
Okay. Okay.
Uh, Basically, the transformer architecture has an encoding and a decoding part. Um, and BERT is really only about understanding what the language is saying or asking. And so
Mhm.
it focuses on the encoding part, whereas GPT really is focused on the generation part, the decoding part. So that's kind of where those things went separate. And then people just, twiddling and optimizing on the models all over the place. But the point is, custom hardware is offloading work from CPUs. Um, there's no point trying to mine Bitcoin on your computer because you've got farms of ASICs, application specific ICs in warehouses in Iceland that are powered by geothermal energy and cool air wafting through the data center. So they don't need to air condition it. So they basically have like free electricity and very low operational costs. And the actual calculations of the hashing algorithms is done in custom hardware. There's no way a CPU or GPU based system will compete with that, either in performance or in cost. So this is again why so much about our industry is going to be about where do you locate your data centers? Where do you locate your code? Where do you locate the data itself? Is it on premises? Is it on device? Is it nearby? Right? And so we need this computational landscape fluidity that things like WebAssembly and LLVM will provide.
And did we, just for our listeners, did we define LLVM before?
Sorry. LLVM is the modular compiler architecture that Christian Lettner and his graduate advisor did at the University of Illinois Urbana-Champaign. Probably the most successful graduate project ever, because it's the compiler technology that Apple uses now. It's the compiler technology that NVIDIA uses. It's the compiler technology that Sony and Google and all those companies are building tools around it. It's what powers Rust. It's what powers Julia, Swift. It's why Rust and WebAssembly are such close technologies, because normally our compilers have been monolithic architectures. So you like shove code in one side and bits come out the other side. LLVM is broken up into like a library, and it's also modular. So you can have a new front end, but keep the same optimization layer and the same backend layer. So, right, if you're writing Julia, you don't have to do all of that. You just write a new front end layer. If you want to target WebAssembly, you don't, spit out x86 or ARM-based instructions. You spit out WebAssembly instructions on the back end. And so that's how WebAssembly and LLVM work together. Is LLVM is about separating the code structure from the optimization layer, from where the code is actually going to be targeted from an instruction set perspective.
Mm-hmm.
And then WebAssembly happens to be a layer then that virtualizes access to arbitrary resources and functionality, and is sandboxed and yet still high performance.
Right.
Cool. So my question on LLMs, though, since I think everybody knows about them
So
now.
you're saying LLM, not LLVM.
Right. So those are distinct.
Right. LLVM and LLMs, two different. Yeah. So on the LLM side, I think everyone has used it, knows about it. A hype, a danger, or both. I think you have a quote of like, if you're not paying attention, or if you are paying attention, there you have to have a little bit of both there. What's your take on the LLMs?
The quote is, if you think they're not going to change your job, you're not paying attention. But if you think they're going to take your job, you're not paying attention.
Not paying attention.
Right.
Because here, let me share something with you, and you can share this with the listeners. This is the best visualization of what's going on in LLMs, and it demystifies everything, right? So if you take that link, go to it, and then spread it out. On the left, you'll see a visualization of the graph, and you'll see on the right a series of words, and the words represent different paths through the system. So if you scroll, or widen your browser a little bit there, Kito. Okay. So that represents roughly the neural structure and a path through it, right? And you see each one of those paths is associated with a series of tokens. And that really, it just puts such a fine point on that's all this is, right? This is a probabilistic selection of paths through neural structures that happens to have some really cool kind of consequences, right? But there's no agency here. There's no theory of mind here. There's no understanding of concepts here. To to the extent that people think that it understands math or logic problems, it's only because it's seen examples of those math or logic problems. It doesn't actually understand what arithmetic is. And so, um, if you understand what's here, there's a lot of tremendous value that can be done, right? But if you don't understand what's here, there's a lot of risk, and we're seeing it play out in the search space. Just last night,
I could
my
probably
wife was
stop. Sorry.
yeah. Just last night, my wife was complaining that she was having a hard time finding gochugaru, the Korean red flakes spice locally. Like we live near Sacramento. It's a very large urban area, lots of ethnicities and grocery stores and things around. But there's a specific brand she was looking for, and she was having a hard time finding it. And we just started talking about, Sacramento has a very large Japanese and Chinese population, but we just weren't sure necessarily how big the Korean population was. And so I went to Google and I said, how big is the Korean population in Sacramento? And it said it represents 0.4% of Sacramento's population, therefore 460,000 people. And I said, wait a minute. That's suggesting there's like 12 million people in Sacramento, and there's not. There's like 3 at most. And this is coming straight from Google. It's just complete garbage. And it's because there is no conceptual basis here, right? So it doesn't actually understand that this thing that I said doesn't make sense. So that's where RAG and agent systems and things like that are going to help, is because you can rely on the LLMs for what they're good at, which is the linguistic capabilities. That's the part that's amazing, right? Being able to summarize text, being able to innovate. People think hallucinations are bad. That's kind of the point, right? If there were no stochastic random creativity to these things, they would just be big, expensive memorization engines, and Sam Altman wouldn't get his $150 billion valuation, which he's probably not going to get at this point now anyway. But if you understand that the emergent behavior in terms of the text summarization and in context learning and things like that, if you understand how to take advantage of that, this could be a tremendously useful thing as an optimization, not as a replacement for actual thinking. And so when you tie this to search, when you tie this to code development, when you tie this to a bunch of things, you risk brand damage, right? Or possibly even litigation or whatever, because it's spitting stuff out that has no awareness of what it is you're asking it for. And if you just take the simple example of code generation, right? I know everybody's so excited about this. I couldn't give a crap about any of this code generation, because where my head is in stuff that hasn't been written yet, right? Code that runs inside the browser and outside the browser and in edge computing environments, in these sorts of things. None of that code has been trained, and therefore these things are completely useless to me, right? If you're saying I'm trying to solve a simple tax calculation problem that's been done 50,000 times in 20,000 languages, like, sure, that kind of thing you can barf out because it's been trained off of that. But people fail to realize that you're optimizing the least expensive part of software development. You're producing code that is not copyrightable, so you have no legal protection over it, because generated stuff has no legal protection. And it also has no concept of things like power consumption or security or, the kinds of things that we're going to have to worry very much so in modern systems rolling this kind of stuff out. So, is it cool that you can spit out a Python function to add 2 numbers together? Yeah, that's cool. But Python's just a language. So if you give it a lot of good structured, syntactically accurate Python, it's not surprising that it could generate that, just like it can generate poems and things. It's freaking cool, like compared to, what we grew up with. But I would not, with any amount of budget, build something where the majority of the people are using this kind of crap. Because the
Yeah.
studies that are coming out are also showing it's not working out.
Well, also a lot of churn, a lot of
High churn, no code movement is falling, which means people aren't refactoring. Because again,
Mhm.
these things are mostly good at emitting new stuff, not analyzing code for reuse because it has no concept of what does that mean, right?
Right.
I
So
had
do you
a
think, given that, oh, sorry, Kito.
go ahead. Go ahead.
What is are LLMs going to be devalued over time just because we pulled the curtain on Oz, and or is this always going to be just the how to phrase it, just the thing that is going to, you know, overturn or upend our world as we speak, or is this just going to be a wonderful tool, help us look stuff up, but for new stuff it's not going to work out too well, and everything that you just mentioned? What do you think? What do you think
Yeah, no,
that future is?
it is a waypoint, but it is a waypoint that I think we will continue to tap into. We will limit the scope of how we use it. We will use it responsibly. We will put guardrails around it,
Hmm.
and that's what it'll be good for. But it is not a path to AGI. And there are people who have been saying for years, Gary Marcus and people like that, who would say for years that it will run into a wall. And he was publicly ridiculed by the Emerald Mine Error co-president years ago. Um, that yeah, that's going to happen. Well, it is exactly what's happening, and it's exactly why GPT-5 hasn't come out. Nobody knows when it's going to come out. Most of the founders of OpenAI have quit, right? And if they were that close to AGI, and if this was the path for getting there, that wouldn't be the case. So,
Just for our users, AGI
oh,
is
sorry, uh,
artificial
artificial
gen-
general intelligence,
yeah.
right? Everything that we've done so far, even things like Alpha Zero and whatnot, are fairly narrow uses of these technologies. Um, on the one hand, it's very cool that you can start from nothing and train it to learn how to play Go and shogi and chess, but that would be almost completely useless for playing poker, right? Because Go, shogi, and chess don't have hidden things. There's no concept of bluffing, and right, none of that is learned from watching these other rules, right? Or these other games. So we have an extremely narrow capacity. Now, LLMs have kind of broken the mold open a little bit from a linguistic perspective, but the the capabilities that are there, while impressive, again, there's no theory of mind, right? When that means a child learns to evaluate how somebody else will think about something. It's how we develop empathy. It's how we like do problem solving. It's how we imagine. And that's how we become little political animals because you learn to influence people, right? Um, there's a famous test that is given to kids and whatnot. Um, I can't remember what it's called. But there's two characters, Sally and Anne. And Sally has a special stone that she likes. It's a very pretty stone. And she puts it in one basket and then she leaves. And while she's gone, Anne takes the stone out of the one basket and puts it in the other. And if you ask a child, when Sally comes back, where is she going to look for her stone? They will say initially in Anne's basket because they have seen where it is. But they can't imagine that, oh, wait, Sally wasn't here when that happened, so Sally doesn't know that that has happened, right? So a big part of these things becoming autonomous robots and, reusable chat agents and things like that is, I think, going to require some kind of theory of mind. And there's just nothing like that in these systems. So um, it's not demeaning to LLMs to say they're not the future of AGI because they do a lot of really cool stuff. It's just a question of understanding the limitations, understanding the risks, and understanding the value that it provides, and then that becomes exploitable. But right now, a lot of people are wasting a lot of time and money, and I think taking on a fair amount of risk um, by not understanding that, which I
Yeah.
put down to a failure of tech journalism.
Yeah, I can see that.
Yeah.
And journalism in general, picking up on the tech stuff.
Yeah.
So Ian, I had two housekeeping things. First of all, for those who are listening, the site that Brian asked me to load up is called mobio.com/mine. I'll put it in the show notes. And what I was looking at was essentially a 3D image of an LLM and the ability to sort of look at different pathways throughout it's a neural network, basically, right? So look at different pathways and then see what text is being generated. So it's a really good sort of visual representation of how they work. I'm going to spend a lot of time playing with it. That's awesome. And so Ian, are you there? Ian just jumped on. But I don't know if
Oh, I
he's
was wondering why you said Ian. I'm like, what?
yeah. Okay. So he's not really here. He's sort of here. Okay. We are almost out of time. Did you want to talk briefly about killing off the web, Daniel?
Yeah, I was
I
just
don't.
really quick, Brian, just what your thoughts are on, because you've been a proponent of open web. I had talked about self-hosted, where people are owning their own blogs again. There's a movement of, just owning everything again and using RSS feeds and other things like that and getting away from, mobile apps and things like that. Do you think that movement's pretty solid? How do you feel
I
about it? Things
I
like
think it's
that.
gaining momentum. It is gaining momentum. The uh, the ability to control your information and how it's being used is key. We've learned that convenience comes with pretty severe trade-offs of control, and the the standards that have been produced, RSS, Atom, things like that, worked really well, right? We love them because it facilitated a decentralized publishing platform. But people who are VC backed and trying to acquire and own don't like them because they don't like open standards. So I think we're seeing both with the success of ActivityPub, which is driving the Fediverse, um, a move back towards RSS technologies like JSON-LD, linked data, right? We're going to have, I think, renewed interest, self-interest in heading in that direction. So the more people try to close things off, I think the more there's going to be an interest in re controlling it. And that's where things like IPFS and a bunch of other stuff are really interesting as well, but we don't have time to talk about
IPFS
that now.
stands for
Interplanetary File System.
thank you. Oh yes, I have seen this before. Okay.
Yeah.
The 2-second summary of that is we're gonna be putting people on the moon soon, or at least that was the plan. Who knows what's going to be done anywhere. There are some people who think we're going to be putting people on Mars. They're just high. But the point is, even if we have technology and devices on Mars, we need it to communicate with stuff on Earth. And there's no real need to reinvent um, communication protocols and whatnot, uh, like HTTP and whatnot. So IPFS is an attempt to merge new transmission mechanisms and content-based addressing with the web to help route around censorship, to deal with large latency communication mechanisms. But it's also going to work really well on Earth, and we're starting to see some really cool uses of that. So that could be another topic sometime.
Yeah. But hey, Ian.
I'm here. I'm late, but I'm here. And fascinating discussion. I caught the tail end of that. And Brian, it's great to see you on the call today.
Thanks.
And I quickly glanced at your bio. I see you're a liberal arts educated software engineer, a fellow student of philosophy. So it's great to meet you. I'm also a software developer, passionate about programming and AI and all these subjects. And I'm also, trained in liberal arts. So I have a question for you about that. You mentioned theory of mind as a prerequisite for AGI. And I'm curious to know if you think any other concepts from the field of cognitive science apply to what's going on today in the industry with these companies kind of battling it out for supremacy in the AI field. Are any of them? I mean, their goal seems to be AGI, but what about consciousness, or what about intentionality, or some of these other topics that come up in cognitive science? Do you see if those factor into the discussion at all? And
I certainly do. So there's a big, as you know, a big argument about how much of the human mind do we need to replicate, right, in order to achieve some of these capabilities. And there are some people who think, without a model for metabolism, right, you're not going to actually get to the same place, because brains are embodied things, and we're seeing now even things like memory is not purely co-located in the brain, but is capable of being triggered in kidney cells, crazy stuff like that as well. But on the other end, we've seen such big developments in just one approximation, which is the artificial neural network. There are people who think if we just go bigger, 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 that's going to be the path of achieving some of this self-awareness and whatnot. I land somewhere in the middle, right? I think we need a better model of memory, right? So humans have episodic memory and whatnot. But to the extent that we remember things, that triggers a part of the brain that's kind of the same part of the brain that triggers the theory of mind, right?
Right.
In order to understand how somebody's going to react to you, you kind of have to run a simulation in your head, like what happens if I do this, right? But that's also how we remember things, right? And that's why memory can be so faulty, is we have these like impressions that we then kind of replay in our mind if they are important or powerful or impactful or whatever to us. But it's the same kind of simulation mechanism,
right.
And so
yeah, sorry, please conclude your thought.
I was just going to say, I think that there are the more we know about the evolution of the brain, the more we're going to understand how these things actually facilitate the learning process. And complexity is not the only thing, right? Bumblebees can learn and teach each other things, and they have much less complexity than say a large language model.
Right.
There's an innateness to our capacity here, that's not linguistic, right? Linguistic language is really just kind of a consequence of some of these things.
Yes.
So I don't have a specific answer to your question, other than that I think it's somewhere in the middle.
You brought up memory, which is a great topic. If we talk about, like, as software engineers, programmers, our interface with AI is probably through our coding assistant and our IDE. And memory seems to be one of these huge gaps where the tool has forgotten a suggestion that it gave you literally 5-10 seconds before, and has no concept of continuity of style or of thought. Like it seems to be dropping random suggestions continuously. Is this a symptom of how the AIs, the large language models, have been trained, or is it a symptom of the implementation? There's just not enough storage to hold the recent suggestions in memory, or what do you see that as a function of?
So the models fascinatingly learn facts, right? It's really kind of quite compelling that you can ask ChatGPT about a movie or a book or something like that, and it can pull out details about it, but it can't be updated, right? It in and of itself it has to have the equivalent of like you every year rereading every book you've ever read plus 100 new ones, right? That's not an effective learning strategy. So what you're describing, I think, is largely a usage pattern that we have discovered. The emergent behavior in the higher complex models is able to do in context learning, right? provided with evidence, right? This is the basis of RAG. This is the basis of a bunch of other things. If provided with evidence here, um, we can say, don't rely on what you know, rely on what you can do, and apply that to this,
Yes.
right? And so
Yes.
that's how we can update large language models data access. But the point that you're making is that has to continue to be part of the conversation.
Right,
So
right, right.
in order to establish like memory buffers for AI bots, you generally have to re-tokenize over and over and over again everything that's already happened in the conversation. Because
Right.
if you come up to an LLM and you say, like, "Hi, I'm Brian," and you're like, "Hey, hi Brian, how are you? What can I do?" And you say, "What's my name?" And it's like, I have no idea, right? You have to give it the context of what it has, and then you can say,
Yeah.
"What's my name?" And it'll say, "Oh, well, you told me in the first thing that that was your name."
Right, right. It makes you wonder too, Brian. I think like the more that the ideas being proposed, the value proposition of AI is being maybe a replacement for like a low skilled programmer or junior programmer, or who knows, maybe eventually a higher skilled programmer. Is that really a reliable software development partner if it can't even remember, a few suggestions back? And, it makes me think about a quote I saw on Twitter the other day on X from Grady Booch, author of UML books. And he asked the community, like, simple question, like, where do I put my prompt in version control for the system
Right,
that the AI just generated, asking for a friend, like
right, right,
that
right.
becomes configuration management, or how do we, if we partner with AI to build the software, the future, right? How will be able to, interact with these tools in a way that's reliable, repeatable, intelligible, right? If, it's one thing to build something from scratch, but to maintain it, support it, and what are we assuming AI developed software will be bug free for
Yeah,
forever?
yeah. So
How does that work?
I think you came in after this, but one of the things that I pointed out was all of these tools are optimizing the least expensive part of software development, which is the creation part, right?
Right.
And simultaneously, they are making it harder to do the more expensive part, which is the maintenance part. Um, and it's also not copyrightable, so you don't have any legal protection for this. And then, as you indicated, it has no conceptual basis for understanding what it's doing. And so the studies of the code that's been produced have shown, as you suggested, the only real benefit is to junior developers, because it's like having a pair, right, of somebody who's seen stuff, right, and that can help you bring it to mind, but it doesn't still really understand the larger concept of what you're doing, and that's why I have literally zero interest in what's out there right now. Um,
Right.
but I think part of the story and part of the move towards agentic systems is about changing the narrative, right? And the narrative is, don't ask the LLM to do stuff that it's not good at. Use the LLM for what it is good at, but
Mhm.
couch it in a larger workflow that's driven by rules and context and awareness and has access to databases and
Yes.
APIs and things like that. Um, that's the part where I think things are really interesting.
Right. And I do apologize. I joined late. I may have missed this discussion. Did you guys talk about DeepSeek at all? The new
We did.
contender?
Yes.
Yeah, yeah.
You did?
Yep.
Okay.
The
So is that
R1
an
model.
example of a RAG oriented AI implementation where, from what I understand, a very simplistic understanding of it, but it has like as if it was a doctor behind the scenes, a lawyer, an architect, an engineer, and whenever it needs like expertise, it changes persona in a way. Is that a fair assessment?
Kind of, but it's not really doing anything all that new. It's relying on pre-training and fine-tuning and transfer learning, and um, those are all things that you can take an LLM now and turn it into a sentiment analysis machine, or turn it into a predictive token machine, or you can whatever, right? You're generally dealing with a trade-off of how much context do you give it versus what can it kind of just naturally do on its own. And then there's usually a cost associated with that because you're paying for the tokens, right? So you either, with RAG systems, you're pulling out relevant context and saying, answer your question against this, but you're doing that over and over and over and over and over again. So you're paying for that over and over again. Another option is to fine-tune the models into more optimized form for the thing that you want, and that's just another choice, right? It's not that one is better than the other. It's that these are all trade-offs. Um, my short summary, just to avoid rehashing it, is I don't think DeepSeek is interesting for any reason other than the fact that it was the Chinese, right? That's it's doesn't change anything really. It doesn't. It's just it got there efficiently, particularly when they are politically shut off from the most advanced chips. But we've already seen, a half a dozen other approaches in terms of like photonic computing, biological computing, large language models that don't use the matrix multiplication quadratic functions of the transformer key value stuff. All of this is just about incremental advancements, whether it's in reducing the effort and the cost to produce or what's capable. But DeepSeek is not any big leap forward, other than the fact that non-VC backed Western companies are responsible for getting us there.
Right. Okay. Interesting.
Which I think undercuts the whole value proposition that Sam Altman is trying to exploit very, very quickly because he has no moat, he's got no founders, he's got no next step. Right?
Right.
So he still has the name recognition, he still has the cachet, but to turn that into a $150 billion IPO, he's got to move fast, and he's got to keep lying to everybody about the state of things, right?
Yeah.
He's doing the same thing with fusion, right? He said, "Oh, we're going to have industrial scale fusion in 5 years," and don't think that's going to happen.
Well, I think I'm going to take over hosting duties. Kito has had to step away here, but yeah, let's head over to the picks since we've had a good nearly hour and a half here. And the picks portion, of course, is finding a technology or sharing a favorite technology of yours that others should know about. And Ian, if you could think of one. As we do this list, we're going to give this one over to Brian first, since he's our guest. And Brian has Let's Loop. Can you tell us a little bit more about Let's Loop?
Sure, it's a kind of left field selection. It's not new. It's something that I used to do a lot more with many years ago, and I kind of fell away from it, but came back to last fall. It's just a great way for discovering music. It's like shared playlists, and it pulls from YouTube and other kinds of places, and it's got access to all this kind of stuff. And so it's a cool way to share your mood or new music you're hearing about. And it's just, to me, it's a nice balance of usability and availability of content. And the people that are there are really kind of like hardcore music nerds like myself. So
good, excellent.
I'm on there. Let's Loop /BSLETTEN. If anyone wants to follow, but that's my pick. We need some joy.
Yeah, we do. Kito has J Taccuino, JTACCUINO. I was just taking a look at it. This looks like a JVM based notebook, something that I think we've had kind of like with Zeppelin, and maybe there's another take on it. It looks like it is powered by Java FX. So that will be Kito's there. And Ian, do you want to bless us with a pick?
Yeah, I've got a couple of picks. One, and kind of in both camps. One is an entertainment service as well. I recently trialed this thing called Quello. I think it's pronounced QELLO. I'll drop the link in the show notes. But basically, it's a live concert archive. It has a lot of pre-recorded live concerts. If you like to watch your favorite bands, like epic concerts, with in video, right, video format. So I personally love live concert, especially recorded stuff. Well, live is always better, but I love to watch the recorded live concerts as well. My wife hates it, so it's been difficult for me to get time watching some of my favorite bands and acts live, and so this is great because you can stream it from anywhere, your phone, and it's it's good. So Quello is my pick. I found a few nice concerts that I like to watch on that. On the tech side, I have one pick, which I've been really enjoying a lot lately. There's a company called Mac Stadium that provides Mac hosting for bare metal Macs. So basically you can rent a Mac, especially now with the new Mac, the M4 generation came out, and so they have the latest and greatest Macs. But what I'm using it for is, CI/CD pipeline, and they have a feature called Orca, O-R-K-A, which is Kubernetes, Apple on Kubernetes. So it's, to my knowledge, the only provider that I've found that has achieved that. But what they have is this ability to deploy VMs on Mac hardware ephemerally. So, if you're running your builds through any of the modern CI/CD pipelines, GitHub or Bitbucket has it as well with their pipelines. They usually go for these ephemeral agents where, they provision a VM for you, whatever OS you want, Linux, Mac, or I think some have Windows, obviously. You build your code and then it shuts down the VM and it destroys it, right? It deletes it. So this is the same thing, but with Mac hardware, and with Mac, you can run Sonoma or Sequoia, whichever version of Mac you're using. So I do a lot of Mac OS development on the side for some hobby projects that I have. And so this has been great, running 10 VMs on Mac infrastructure with Kubernetes it's been really awesome. Enjoying that.
Oh, that sounds amazing. I may even need to take a look at that, because I've been looking for a solution for something like that for quite a while. Excellent. Well, mine is Pandoc. Pandoc is nothing new, but Pandoc is an application that does a lot of conversions for you. I used it one time because I had to create, usually I use ASCII Doctor to create slides very quickly if I need to present something very quick. So Pandoc was there. What I did is I told Pandoc, hey, go to this HTML document, grab it and convert it into ASCII doc for me, so I could convert it into slides, and I need to do it really quick in under an hour. So, but it has multiple conversions for just about anything: ASCII Doctor, Markdown, LaTeX, and a few others. So, wonderful tool to use. And Brian, you mentioned you'd like to use it extensively.
Well, I'm migrating my presentation system. I've been doing HTML based presentations for 20 years in various forms, and I have a pretty good solution, but there's a lot that I want to modernize and update it with. And so I'm using something called Quarto, Q-U-A-R-T-O. Jeremy Allaire behind Cold Fusion and some other folks are behind it. But it's a really nice publishing platform for blogs, web pages, journal articles, presentations, things like that. And it uses Pandoc behind the scenes, but it's just kind of like an abstraction layer on top of it. And so you'll be able to take Markdown and say generate Reveal.js presentations from it, or PowerPoint, or things like that. So it's really nice.
Yeah, I think it's definitely a must-have tool. The other one, since we're talking about self-hosted and Fediverse and all that good stuff, and particularly in light of the TikTok shenanigans that we were experiencing maybe 3 or 4 weeks ago, and whether it got canceled. It was removed for about a day, but something had come up to the forefront. This has been around a while, called Loops Video. This is part of the Fediverse, so it is a TikTok-based Fediverse ActivityHub-based video, much like TikTok. Right now, they're not accepting any users, but I think what they're trying to do is catch up with some infrastructure, because it caught on by wildfire when the TikTok news started surfacing. So keep an eye on that. And if you want to share your videos in a more free way, I think it'll be a wonderful platform that you can use.
I've been using it for a while, and I'm astonished at how quickly it's growing and how creative and everything people are being with it, and the fact that it's not being done in a way that can be controlled or shut down.
That's right.
Beyond initial,
and I think that's another aspect of
gatekeeping, but
right. And I think that's another aspect of IPFS as well, is that it's a file system that's just uncontrolled, and so I think we're going to be needing to look at more of these technologies, particularly seeing how the world is moving towards a more controlled state. So very good. Cool. All right. So yeah, and let's go ahead and tie things up. We are partners with other podcasts, including Off Heap. So take a look at that podcast and Java Pub House. Some events that are coming up. We have Dev Nexus coming up on March. So I think tickets are definitely still on sale. It is the largest Java conference now within the United States. I don't know if it's global or if it's just the United States, but that'll be in Atlanta, March 4th through 6th. And Brian and I are part of No Fluff Just Stuff. And we will have a list of shows. I think some of the dates had changed, but I'm pretty sure St. Louis is the first one coming up April 4th through 5th. And then Columbus is April 11th, or I don't know if that one got changed.
No, I think Columbus is there.
Yeah, take a look at the No Fluff Just Stuff website. We will have shows for Seattle, of course, St. Louis. We usually are at Nova, and Northern Virginia, Boston. Those are usually a lot of the cities that we will often visit. And again, leading technologies. Brian will be there. I may be there, and really great conference. Our talks, by the way, are an hour and a half, so it's not just, hey, here's 45 minutes, blah blah blah, and good luck to you. So we usually go a little bit deeper than most conferences. And then Arc of AI, which I think Brian Sletten is, a part of the group. Can you tell us more about Arc of AI?
Sure. It's a new conference in Austin, end of March 31st to April 3rd. But what's interesting about it is beyond sort of like the state of the art, cutting edge kinds of discussions. It's got a substantial, interest in ethics and career development and things like that that are part of it as well. So it's how these technologies will both positively and potentially negatively impact you, but also how giving people some deeper thinking about what's coming. So it's a nice wide set of topics that I'm happy to be part of.
All right. And Ian, since you joined us, any events or other things in your part of the world that we should be aware about? And also, how are you doing? Yeah.
I'm good. Thanks for asking, Dan. Yeah, I'm good. It's good to be back, starting on new year with starting on the right foot with the new podcast. And yeah, I think for the conferences, there's one I'm aware of. It's JCon 2025. Kito will be speaking at that conference, and he's graciously extended a pass in my direction. So I'm very interested in that. I think.
What city is that in?
I think it's in. This is a good question. I am looking for the.
Where are you going, Ian?
In Germany. It's in Germany. Okay.
It is in Germany. I kind of thought so. I think Richard Feitner is an organizer for that. I'm not mistaken.
Yeah, it looks like a pretty good lineup. Riza Rehman is there, and a lot of speakers I recognize. So, I mean, this is exciting to go to a Java conference. So, especially in Europe, May 12th to 15th, 2025, JCon 2025 in Germany.
All right,
Cologne.
excellent. All right. Well, excellent. Well, thanks everyone here, and thanks to Kito Man. He had to step away, but wonderful, wonderful podcast. And thanks again to Brian and everyone here. I hope to have all of you to have a good year with not much chaos, but yeah, and thanks for joining. Appreciate it.
Thank you.
Thanks, everyone.